Okay, so on this lesson, we're going to be looking at linear regression. So remember, we've talked about linear before. It's a straight line on a graph. And in the equation, it has a y equals, and then it has an x. So we're going to be talking about correlation coefficient R. So the first thing we're going to look at is linear regression is a statistical method that fits a line of best fit to a set of data. So the equation that results from your linear regression is sometimes called the regression equation or the regression line. So in order to get that linear regression, you're going to need at least 2 points. So 2 data points are required to calculate a linear regression equation using a calculator or mathematical software, which we'll use a calculator. So the correlation coefficient, represented as the R, measures the strength of the linear relationship. So whenever you find your equation, you're going to know what R equals. It gives you what R equals. So if R is 0, that means there's no correlation between your data points. If it's -1, that means it's a perfect negative correlation. If your R is +1, that's a perfect positive correlation. And then you can look to see the other things in between each one, okay? All right, so we're going to use a calculator to input the data, and then we're going to find that line of best fit and the correlation coefficient. So we've actually used this before. We're going to be using stat edit in order to insert our points into the calculator. Before we do this, though, I want you to turn on the regression, the R. I want you to turn that on your calculator. So make sure you go ahead and do this with me. Okay, so on your calculator, you need to go to second, and then your 0, which is catalog. And then you're going to push the X to the -1 button, which is D. And then you're going to go down to diagnostic on. So you see it says diagnostic off. You're going to press diagnostic on. So press enter, and then press enter one more time. It should say done, which means now when you find your equation from stat edit, you're going to be given also the R value, okay, which is what you need. So now let's go ahead and go to, if you go back to your notes, we're going to insert these points into our stat edit. So if it helps you, you're welcome to make this a little table so you know. So notice this first point that we have is 0, 9, 1, 7, 2, 5, 3, 3, and 4, 1. So again, you're going to go to stat edit and type those in. So stat is right below delete. Edit, so press enter. And if there's anything in your list, you're welcome to go up to it and then press clear and then go back down. It should clear it out. But make sure that you have an L1 and an L2, because that's where we're going to type the X's in L1, the Y's in L2. So in L1, I'm typing in the X values, which were 0, 1, 2, 3, and 4. And then the Y values I'm typing in L2, so those values were 9, 7, 5, 3, and 1. So once you've inserted your data into your L1, L2, you're going to go back to your home screen, so second quit, and you're going to go back to stat. You're going to go over to calc, and you're going to choose linear because that's what we're talking about. So number 4. And then make sure X is L1, Y is L2. You're going to go down to calculate. And then notice it gives you your Y equals. You're going to plug in for A. You're going to plug in for B, which represents your slope and Y-intercept of your linear. And then notice it gives you your R, which is -1, which means that means you have a perfect negative linear regression. So go back to your notes, and we're going to fill that in for our line of best fit is our equation. So we said Y equals -2x, and then our Y-intercept was 9. The correlation coefficient, which is R, was -1. So if we look back up at this little chart here, when R is -1, that means you have a perfect negative correlation. What that means, perfect means it goes through every single point on your graph. And notice this does give you a straight line. It has the same slope throughout. Okay, notice part B is not quite the same. So we're going to have to plug in these points also. So again, if it helps you, you're welcome to draw a little table. You don't have to. You can just go straight from your graph. So looking at your points, these are X's and these are Y's. So 1, 3 is a point. 2, 1. 3, 2. 4, 4. 5, 6. 6, 3. 7, 4. 8, 7, and 9, 6. So those are the points that we're going to insert. So we're going to go to our table on the calculator. I'm going to go ahead and, so you're going stat, edit. Here, I'll show you. So remember stat, edit, and then again, remember I told you you could just go up to the top, press clear, and then go back down. Don't press delete though, it deletes it. So just press clear. I'm going to go back to my notes so I can see my points. So my X's are 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then my Y's are 3. Make sure they line up. 3, 1, 2, 4, 6, 3, 4, 7, and 6. So this is what you should be seeing in your calculator when you type them in. Now you're going to go back to your home screen, so second quit, go back to stat, go to calc, and then we're using linear, so number 4. We already know list 1, list 2 is X and Y, go to calculate. All right, so we are going to write our equation down. We're given the A and the B that we're going to substitute in for our slope and our y-intercept. And then we're looking at the R for the correlation coefficient. So let's go ahead and write that down. So the equation, it says to round to the nearest thousandth, which is 3 decimal places. So that would be y equals 0.55. You can put a 0, you don't have to. X and then plus 1.25. Again, you can put a 0, but you don't have to there. So that was the equation we found from inserting the data. And then the R, which was the correlation coefficient, was 0.753. So if we look at the chart here, it would be in the middle of this. So this is a strong positive correlation. Which means your slope would be positive. Notice it is going up the direction. It's positive and it is pretty strong. So it goes through the majority of the points whenever we draw that line through it. So this is called linear regression. So now let's flip on over. We're doing the same exact thing on the calculator. We're going to insert our data into the calculator. We're going to determine the line of best fit, the correlation coefficient, coefficient, and we're going to interpret the meaning of it. Then this is the part that's different from the front. We're going to be graphing the scatter plot and the line of best fit on your calculator, and then you're going to sketch it down below. So go ahead and start plugging these values into your calculator. So I will do that. So stat edit. You can press clear at the top if you want to clear it out before you get started. Okay, so then we're going back to stat calc number 4. So our equation, we're rounding to 3 decimal places. So we should get 0.152x and then plus 3.572 for our y-intercept. The r was 0.215. So if we look back at that chart, if you need to, that would be somewhere in between 0 and 0.3. So that would be a weak positive correlation. Okay, so that was a review of what we did on the front. Now this is the new part, so make sure you're following along with your calculator. Now what we're going to do is we're going to make sure that our points that we plugged in are graphed. So you need to go to y equals and see at the top, I'm going to clear this out so that way, so make sure you clear out your y1 and y2. I'm going to go up to the top. Notice it says plot 1, plot 2, plot 3. I'm going to go up and highlight plot 1, and I'm going to press enter and then go back down. Notice now that the plot 1 is highlighted. That means your plot is turned on. So if you were to press graph, you would see your points that are listed in your stat edit. Now it also wants us to graph that line of best fit equation that we found. So there's a way that we can do this without having to type that equation in. So if we go back to, do this with me, go back to stat, you're going to calc number 4. Notice right here where it says store regular equation or equation, you're going to click on that. And then you're going to go to this right here. So you're going to go to VARS and you're going to go over and you're going to choose number 1, which is function. And we want the equation to be inserted and stored into y1. So press enter on y1. Now calculate. We'll go to y equals, and notice the equation, the line of best fit was inserted in there for us. You can go over and look. That way it has that whole decimal there, and we can press graph. Notice it graphs it for us. So we're going to be sketching this on our paper. So I do want you to plot the points correctly, and then you can draw your line of best fit through it. So when we go to our plot here, we only want these values because we're not using any negatives. So go ahead and plot. We know our x's are going from 0 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then smallest y is 0. It goes to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So go ahead and start plotting those points from our table up here. So 0, 6. And then 1, 2, 3, 5, 4, 3. That point was a little off. 4, 3, 5, 0, 6, 5, 7, 8, 9, 6, and 10, 4. So those are our points, and if you look at your graph, it's going through, we're kind of sketching it. We know the y-intercept is between 3 and 4. So there's our line of best fit. You're just kind of sketching it to kind of see. So notice that's why it's a weak positive correlation. It's positive slope, and it's kind of weak because it's not going through many of your points there. Okay. All right, so we're going to, I want you to, on your own, try this one. So press pause on the video, go ahead and insert those, find your line of best fit and all of that stuff, and then you can press play and I'll give you the answer. So you should have got y equals negative 0.236x plus 4.091. Your r should have been negative 0.603, which means that you're going to have a moderate negative, because it's a negative slope, correlation. And then sketching your points, you sketch them on the graph and then draw your line. Your line of best fit should have been decreasing. So after you plotted all your points, your line should have been going down. So I'm just going to save some time on that. Just make sure that you're plotting your points and then drawing that line of best fit. Okay, so let's go ahead and skip over to the back. Now it says we're given a word problem. The Volleyball Booster Club raises money for the volleyball team by selling Spirit shirts. The price of the shirts and the cost of having them printed vary slightly each year. Data from the past t-shirt printings and sales is included in the table. We're going to use this data provided to create a linear model that the Booster Club could use to predict their profit in the future years given an estimate of the number of shirts that they expect to sell, round to the nearest dollar. So we are looking for that line of best fit. So I'm going to go ahead and go to Stat Edit on my calculator. I'm going to go up to the top and press clear so that way I can start inserting my table. So I'm inserting the table from the table that I have on my paper. So my X's are the top, which is the number of shirts sold. So I have a 25, 40, 35, 50, and 45. My Y is the second in the table. So that would be 175, 420, 270, 500, and 340. So that's my data points from my table. Now I'm going to go to Stat Calc number 4. I'm going to go to Calculate, press Enter. So it gives me my A and my B. Okay. Now, since this is a real-world situation, let's go ahead and, since it's 11.9 and a negative 125.9, let's go ahead and round that. So, because it says an estimate, so we're going to go ahead and put y equals 12x minus 126. Okay, so we're going to interpret the meaning of the slope and the y-intercept with this problem. So 12x, that represents your slope. So your slope is 12. Notice your x is the number of shirts sold. So looking at it, that would mean that each shirt sold was $12, because 12 times the number of shirts would give you that price of the total shirts sold. So that 12, the slope, is going to represent $12 per t-shirt sold. Okay, and then the y-intercept was a negative 126, and you're taking it away from how much you've made from selling the shirts. So that y-intercept of negative 126 would have to represent the cost of printing the shirts, how much it cost you to make the shirts. Because you're having to take it away from the amount of shirts sold, because we're talking about profit. When you're talking about profit, you're always taking the total sales. If you need to write this down. You're taking away the cost to make the item. That should give you your profit. Okay, so it says, what is the value of the correlation coefficient? So if you look at your R there, it was 0.910 after we round it, which means that it has a strong positive correlation. Which means it fits it pretty well. It says use your calculator to create the scatter plot of the data, graph the regression line on the same line. So we're plotting those points. Now here, these numbers are pretty large. So I would say you probably want to increase maybe by 5s or 10s, however you want to do it. So I'm going to do by, let's do 10, 20, 30, 40, 50 on the X. And then the X-axis and Y-axis doesn't have to increase the same amount. So on the Y, I'm going to increase by 100. 100, just make sure you label it so you know. This was 10. So 100, 200, 300, 400, 500. So plotting your points, X is 25, and then your Y is 175. 40 is 420, and 35 is 270, 50 is 500, and 45 is 340. Okay, so I'm going to review you of how you can insert that equation into your y equals. So I'm going to go back. So go back to stat, go to calc, linear, go to the store down here, and then remember you're using the vars, V-A-R-S. You're going over to y, function, and you're going to save it into y1. So then when you press graph, you should have your points and your line. Now notice here, we can't really see it because if you remember, we adjusted our scale on our X and Y axis because we had larger numbers. So you might want to go to your window and change it. So our X, remember we started from 0 and we went to 50. So I increased by 10, remember? And then we started at 0, we went to 500. Remember, I increased by 100. So your scale, that means how many increments. So each increment is 100. Each increment on the X was 10. So that's how I graphed it on my paper. Notice it's going through, and it's really close to those points around it. Okay, so you can adjust your window on your paper to kind of see what it would look like. Okay. All right, that's linear regression. If you have any questions, please let me know.